Okay, so I've got a meter stick and 3 balloons here, and I'll explain what's going on in just a second. This is just for scale. Hopefully we can get this measurement. I have a way to calculate it if not. Alright, so there we go. That's the center to center distance between these balloons. Go ahead and back it up, Angus. So the idea is these balloons are hanging from some threads, and I believe the thread is about 95 centimeters. I'll give you all the parameters at the end. Let's not worry about that. But the fact is I have these 3 balloons hanging from a string, and they're essentially electrically neutral. I know that for a couple of reasons. One, I wore gloves to make sure I didn't get any oils on them. That's for some other reason. And I used this to inflate them. The idea here is now I don't get humid air from my breath in there, and so sometimes this helps these static charge demos work a little better. It's a humid day, so I'm pulling out all the stops. Alright, so now what I'm going to do, I'm going to try and apply approximately equal amounts of charge to these with this spur. 2, 3, 4, 5, 6, 7, 8, 9, 10. I better get both sides. Now because these are not good conductors, I got to charge all of them. 5, 6, 7, 8, 9, 10. This is a good time to playback speed 2.0. Obviously, this is not very perfect. Whoa. Whoa. Get this one. Uh-oh. It's charging. You get there. Now, give me a sec. Jeez. I guess I should have charged them a little less. Okay, what we're going to do is let these things come to equilibrium here. It's not a perfect equilateral triangle. Looks like the orange one has the most, but Angus, if you could try and get a shot from underneath and we'll get the distance. Let me try and measure it here first. Angus, can you shout it? Oh, geez. So here's the problem. Bring in any other object, it changes the polarization. Well, what you can do is you can guess based on the size of the balloons, which I'll give you in a minute. So you're going to have to estimate the size. And my kids are here, so we're going to have to wrap this video up quick. Angus, can you get a shot of the whiteboard?
Yeah.
Okay, go. Hold on. I'm going to go up there and help you out. Oh, these balloons are going crazy. Okay, look at the whiteboard right here. So, I measured all this stuff out for you. This is 95 centimeters plus or minus 1. That's from the, whoops. Oh, that's right. Sorry. Okay, so 95 centimeters plus or minus 1 to right here. The circumferences of the balloons, somehow I managed to get them all very close to 64, the circumferences. So let's say those are 64 plus or minus 1. The mass of 1 meter of thread is 0.07 grams. And I massed the balloons themselves. 16 balloons are 28.42 grams. So hopefully from this you can determine if the weight of the air inside the balloon is negligible or not. You could get the weight of the balloons, and hopefully what you could do is figure out how much charge is on each balloon. So let's take one more look at that thing now that it's equilibrated. Try to come this way and go slowly. So if we walk too closely and the wind affected, it's pretty much an equilateral triangle. I'm going to try and get this meter stick close. Angus, you just estimate it based off your view. I'm seeing maybe 40 centimeters on a side. Hopefully you can kind of tell there. We're blocking the light. Oh, this green screen. Hold on, one more shot. Oh my God, let's call that good.